Hello everyone, I am Alok Kumar Sahu. I welcome you all to this course on thermodynamics. So here we are going to discuss some probable questions for GATE and ASC, as well as these questions will be helpful for those students who are preparing for BARC and IPATE, which is to be conducted this year on probably September. So these examples which we'll be considering here, those are also important from that exam point of view. So let us start that. So this is the first lecture on this course. So without wasting time, let us move towards our question. So this is the first question what we have considered. So first of all, you try to solve it by yourself. Then what's the solution of it? Okay. So let us read this question. So here it is telling that 2 kg of a substance undergoes the following changes in a cylinder piston arrangement. So this is given that this is a cylinder piston arrangement. So that's how we can assume that this is a closed system process. So all the state conditions are given. So pressure at state 1 is given as 5 bar and volume is given as 0.1 meter cube, and pressure at state 2 it is given as 2.0 bar and volume is given as 0.25 meter cube. So it is asking to find out the work done in each case. So there are basically 3 cases which are given to us, and in all these 3 cases we have to find out the work done. So in our question or in our exam we may find in any one process basically. So in any exam we will be getting one question. So I have taken 3 probable questions which can be asked in any exam. So let us try to solve for all these 3 processes. So first process is telling that the pressure, that is P, varies as a linear function of volume. Okay. So first let us try to find the solution for process A, that is statement A, you can say. So let us see it. So for that let us try to draw first the process diagram. So as the pressure is varying linearly, so we can define the state over here. So this is the state 1 and this is the state 2. So in this case pressure is varying linearly. So when we are increasing the volume, at that time pressure is automatically decreasing. Okay. So as I have already mentioned to you, that is this is a closed system. We can integrate that P dV and we can find out the work done like this. So that's how we can calculate, and it will be very simple if we can calculate the what that is our area under this curve. So that will also give us the work done. So that's how we can calculate the work done in this process. So let us try to calculate the work done by considering the area. So if we be considering the area over here, so area under 1 2, so this total person will be our work done. Okay. So first of all if I am taking this area, so this area I can calculate by multiplying by using the area formula for the triangle. So that I have put over here, that is half into base into height. So half, then this is the base, that is 0.25 minus 0.1. So that will be in terms of meter cube, and height is this much, that is 1 dash 2 1. So that will be 5 minus 2. So that will be 3 bar, we can say. And if I will be converting that bar into kilopascal, then I have to multiply with 10 to the power 2, that is 10 square or 100. So this is the area we can calculate. We have by simply calculating by using calculator we can calculate this value. So let us now try to find out this area. So we can assume this is as a rectangle, and if we will be multiplying area that length into breadth, we can calculate the area value. So here we can say this is length and this is the breadth. So 0.25 minus 0.1 will be multiplied with this value, and this is equal to 2. Okay. So this will be wrong over here. So I can say, okay, so this will be not present over here. So only this portion, that is 2 into 10 square, and this much will be there. So if we will be calculating this one, we will be getting as a value, that is 52.5 kilojoule. That's how we can calculate the what work done in this process. So let us go back to next question. Okay, so here we can see that PV remains constant during this process. So if in this case PV remains constant, so let us see how can we calculate our work done. So if PV remains constant, directly we can put in our equation, that is integration over PdV. So that is the work done for any closed system. Okay, so integration of PdV, we can write like this, and as PV remains constant, so multiplication of P and V at state 1, that will be equal to multiplication P2, that is multiplication of pressure and volume at state 2. So from this we can calculate this value, and this will be equal. Then here we can see that PV equal to C, let C is any constant, and if we want to calculate the value of P in terms of V, then we can write it as P equal to C by V. So this value if we will be putting over here, then we can write that is equal to dV by V, and if C will be taken out, then we can write like this, C and dV by V. So if we will be integrating this one, then we can write ln V, and C, that is the constant value, we can calculate over here, that will be putting over here, and it is varying from 1 to 2, that is state 1 to state 2, and only variable is here, that is volume. So V1 to V2, and if we will be putting that over here, then we can write this constant value, that will be multiplied with ln V2 minus ln V1. Simply again we can rewrite this equation as this constant value into ln V2 by V1. So now we have so we have this equation with us, and all these values are known to us. That means V2 is given to us and V1 is also given to us, and from here we can calculate the value of work done during this process, and this is the process diagram for this. So expansion is occurring from 1 to 2, so this process is occurring in this direction. So if we will be calculating this value, then we can calculate somewhat like 45.8214. Okay, try to calculate it so that you can be confident about this. So whatever solutions we are doing here, we are coming from the initial equation that which is for our closed system, which is under the quasi-static process. Okay, so let us move towards the again third process which is given to us. So in the third option, that third statement, pressure remains constant till the volume reaches 0.15 meter cube. Okay, so till the volume is reaching at the 0.15 meter cube, our pressure remaining constant, and after that it is varying with PV to the power n is equal to constant. So let us first try to draw our process diagram. So if we'll be trying to draw the process diagram over here, then let us assume this is the state 1, and state 1 properties are known to us, and this is the state A. That means during this 1 to A there will be no change in pressure, so this is a constant pressure process we can say, and after that there is a vary in pressure, means there is, we can say, decrease in pressure, and at this stage we can say volume is given to us as 0.15 meter. Okay, so from here to here, there it is obeying the relation, that is PV to the power n is equal to constant. Okay, so first of all we can calculate this much work done by taking the simply area under this one, and for calculating this we cannot use the area because this curve we don't know about. Okay, So for this we can put the relation, that is integration over PdV will be the work done. Okay, so let us try to calculate the work done during these two processes. So I have taken this name as A. Okay, so during 1 to process 1 to A process will be getting the work done somewhat like this. So this is the value for this one. Okay, so this is the what, this is the height we can say, and this is the length. Okay, so this total cross-sectional area we can get somewhat like this. So let me show you. Okay, so this is the area. Okay, so this is the area. Okay, so this area we can calculate 5 into 10 to the power 5. So 5 into 10 to the power 5, that I have converted the bar into Pascal. So okay, so and this one is in terms of meter cube. So whatever result will be getting over here, that will be in terms of joule. Okay, so if I'll be trying to convert that into kilojoule, then this is how we can calculate that. Okay, so here 25 kilojoule will be the value of work done during 1 2. So this is A. Okay, now from A to 2, this is a polytropic process. We can say that here Pv to the power n is being obeyed. Okay, so here PdV integration over A to 2 will be obeyed. Okay, so here we know this relation that Pv to the power n is equal to constant, and from here if we'll be trying to calculate the value of P in terms of B, then we can rewrite the equation like this. So now if we'll be putting this equation, that is the value of P in terms of B, then we can rewrite the equation like this. Then obviously C will be taken out, and if we will integrate this one, then we can rewrite the equation like this. And at the state A, volume is VA, which is given to us as 0.15 meter cube, and V2 is given to us as 0.25 meter cube. So simply I have done the integration over here, and we know that P1 V1, that will be P1 V1 to the power n will be constant over here, so that will be equal to this one. So from here I can get a relation between V1 and V1 V2 and P1 P2. So from here I can calculate. So P1 P1 P2 V2, everything is known to us. So from here only one unknown, that is n. So we can calculate the value of n over here. So after calculating the value of n, we can put it over here. So now one thing we can do, so at this C we can write P2 V2 to the power n. Okay, so this one we can say, and at this C we can write PA VA to the power n, obviously. So in this case this will be not valid, so this is not P1, this will be your PA VA. So it is written wrongly, so to correct it, so this is PA and this is VA, and this is VA and this is PA. Okay, so simply if you will be calculating this one, then this is B to the power n, that is B2 to the power n, and this is again B2 to the power minus n. So this will be cancelled with each other, then we will be left with only B2. Likewise here also will only left with B1, that is VA, sorry. So the final equation will be getting somewhat like this: P2 B2 minus PA VA divided by 1 minus n. So all those values are with us now. So simply if we'll be putting all these values over here, then we can get our answer like this, that is 31457 joule. And if we'll be trying to convert that into kilojoule, then simply we can write we can give a decimal number, decimal symbol over here. So 31.457 kilojoule will be the correct answer for this question. So I think all the concepts for this question are clear to you. So if you will be facing any doubt, you can comment in the comment section. So do share it with your friends. So next problem we'll be discussing over here, that is this is the question number 2. So let us see this, let us try to read this first. So again I'll repeat that same thing. So try to do it by yourself. After completion of your solving, then go to this solution part. So here it is telling that an electric heater has a resistance of 40 ohm. Okay, so it is connected across a power supply of 240 volt for a period of 1 hour. So resistance is given as 40 ohm, and voltage difference, okay, potential difference we can say, that is given as 240 volt, and the time period, okay, for 1 hour it is being connected. So we need to find out the work done by the power supply on heater. So we need to find out the work done basically. So what is the electrical work done on the system, we have to find out. So okay, so W we can write electrical power. So let me use the point. Okay, so okay, so W we need to calculate, and W we can calculate like this. This is the, okay, that is V and IT. So this is the multiplication of VIT will give us the what, that is our W, that is the electrical work. So voltage it is given as 240. So V is given as 240 volt, and time it is given as 1 hour. So if we will be trying to convert into SI unit, then we can write okay. So I think I have written it, so we can check it over here. Oh sorry, so I am not written. Okay, so let us try to find out that. So if we will be trying to convert 1 hour into second, so it will be simply 3600. okay, then okay, so here current is not given, but resistance is given us. So let us check that what is given, how much. Okay, so it is given as 40 ohm. So resistance will be equal to 40 ohm, it is given to us. And we can simply convert I in terms of V and R. So I can write V by R. So if you'll be putting this into this equation, then I can write electrical work. So WE will be equal to V. So that will be V over here, and I can be replaced as V by R, and T will be there. So I can write down this one as so W electrical, I can write V square R into T. So V is given to us 240, so this is square of that. R is given 40 ohm, and T we have calculated, that is 3600. So if we will be calculating this value, we will be getting in terms of joule. So try to calculate this one. So let me give you the answer of this. So where is that answer? So let me check. Okay, so you'll be getting 518,400. okay, so this much will be your answer, 518,400. so if we will be trying to convert into megajoule, then I can write 5.18 megajoule. So this will be the correct answer for this question. So it was a simple question, we can say. So in this course we will be moving from the simpler to complex one. So first two questions were more simpler, then we'll be moving towards complex questions. So thank you for watching.